This is number 31 in our Chapter 5 review, where we're asked to express the radical in simplest form. And so we have the cube root of 2 over the cube root of 9, and we know that we're not allowed to leave a radical in the denominator of a fraction. So since this particular problem involves cube roots, we have to think about our perfect cubes. 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, and so on. We want to get a perfect cube in the denominator of our fraction so that when we do so, we will be able to eliminate the radical from the denominator of the fraction. So I notice I already have a cube root of 9. I know that if I were to multiply that by cube root of 3, I'd have cube root of 27, which would in turn give me a perfect cube underneath that radical. So I'm going to multiply the top and bottom of my fraction by the cube root of 3. And by doing so, what happens is cube root of 9 times cube root of 3 is cube root of 27, and cube root of 27 is 3. So I've eliminated the radical in the bottom of my fraction. In the top of my fraction, I have cube root of 2 times cube root of 3, and so when I multiply the 2 by 3, I get cube root of 6. So in the end, I end up with the cube root of 6 over 3. I was able to rationalize the denominator by eliminating any radicals from it.